Hello everyone, this is Abdulkarim Qasim, and today we are going to talk about the high temperature air combustion technology. We are going to talk about its current status and problems. Also, we are going to talk about its research and applications in inorganic materials industry. So in these presentations, we are going to talk about the introduction of high temperature air combustion technology. Then we are going to address the history of high temperature air combustion technology. Also, we are going to talk about the current status of this technology. Then we are going to talk about the method or principles of high temperature air combustion technology, which are divided into two categories or two types, the regenerative and the recuperative, which are both some types of heat exchangers that which are widely applied in many other engineering applications. Then we are going to talk about problems of high temperature air combustion technology. At the end, we are going to talk about the research and application of high temperature air combustion technology. So what is high temperature air combustion technology, abbreviated as HTAC or HITAC, is a process with which we are taking advantage of the heat presented in flue gases after they make the work in gas turbine, for example, in a gas turbine or in a furnace, and which leave the furnace or the gas turbine with high temperature. So this high temperature, which has high enthalpy, so we are taking advantage of such heat to transfer it or to preheat the air which is needed or going to the combustion zone or combustion chamber. This technology is very important because of its benefits. For example, it will save energy, almost it will save 30% of the energy, because if we take, for example, the gas turbine, about 70% of the heat, the amount of heat supply in the combustion is wasted in the form of flue gases in the form of flue gas is going to be or wasted to the atmosphere. So we are using such heat exchanger will benefit us and will give us an advantage of saving fuel and energy. The second one is the flame stability. The temperature will be uniformly distributed throughout the combustion process. Also, we are reducing the amount of nitrogen oxides which are responsible for the ozone depletion and exposing the humanities to radiation which are very harmful to our lives. So as you can see here, this is a regenerative gas turbine. The gas turbine components are the compressor, the combustor, the turbine, and if it is a closed cycle, there is a condenser here, but this is an open cycle. So as you can see here that we are using a regenerator. So a regenerator is a type of heat exchanger that transfer the amount of heat available in the flue gases after making work in the turbine. So transferring such amount of enthalpy or heat to the air after it has been compressed in the compressor, so increasing its temperature, thus decreasing the amount of fuel needed in the combustor. So the history of this technology has been around. It has been developed since 30 years ago, and it has been using low heating value fuels. So as we said earlier, that the excess enthalpy presented in the flue gases is wasted to the atmosphere. So we are making use of such enthalpy, and we are using it in a heat exchanger to increase the temperature of the air before it goes to the combustor. So here let's talk about the current status of this technology. This technology is one of the promising combustion technique that will give us solution for the energy demand, as we know that nowadays the world is demanding the energy and there is energy starving in the world. So preserving such amount of fuel or energy in the world will solve some of our problems. And also because of the contaminations that will pollute our planet. So this technology will reduce the amount of contamination elements or pollution elements such as nitrogen oxide and carbon monoxide, as we will talk about them later. So what are the benefits of such technology? As we said earlier, that it will save the fuel consumption and thus saving energy. So saving energy. Then it will reduce the amount of carbon dioxide, and the carbon dioxide is one of the main elements which is responsible for the global warming and increasing the temperature of our planet, thus leading to catastrophic results which lead to flooding and increasing the level of oceans and seas in our planet. Also, it will decrease or reduce the amount of nitrogen oxide in the form NOx. This compound is responsible for the depletion of the ozone, and also it will let us be exposed to radiation and harmful radiation coming out from the out cosmos, or the out from the sun and the cosmos. Also, it will reduce the equipment size, and this is very important because it will reduce the capital cost of the system, and also it will reduce the other expenses such as the maintenance of the system. So it's the basic principle of the HITAC technology. As we said earlier, that there is a heat exchanger which transfers the heat from hot flue gases to the lower temperature of air. So as you can see here, these diagrams illustrates the types of the methods that are using accompanied with this technology. The heat recirculation methods, which can be internal or external, and these internal and external methods can be of steady or unsteady types, and the steady and the steady types have the categories of the heat transfer modes, which are convection, and the convection is the transfer of the heat from the high temperature fluid to the lower temperature fluid in the form of convective transfer, which is due to the movement of the fluids. And also the second one is conduction, and the conduction is transferring of the heat by the particles and the molecules of the fluid itself. The third one is radiation. Radiation is the transferring of the of heat in the form of electromagnetic or infrared radiation, and these all types can be used for conventional. We are using swirl flows or wake flows, and for the conduction we are using in porous media such the porous ceramics that are used in some furnaces, and also cyclone and pulse combustion. So what's the method of high temperature air combustion technology? As we said earlier, that around 70% of the heat of the combustion is wasted to the atmosphere in the form of hot flue gases, and the temperature of the hot flue gases is around between 400 and 1600 degrees Celsius, and this will decrease the efficiency and also increase the amount of fuel used in conventional combustion system. There are two types of high temperature air combustion technology: the regenerative and the recuperative types of heat exchangers. Regenerative and recuperative. So heat exchangers are type of exchangers to extract the amount of heat available in the flue gases and transfer these or some portion of this heat to preheat the air before it goes to the combustion chamber or to the combustor. So it will save energy about 30%. 30% of the energy will be saved, and also it will increase the air temperature around from 500 to 600 degrees Celsius. So what is a regenerator? What is a regenerative heat exchanger? So as we see here that from the diagram of the gas turbine or the regenerative gas turbine, and we have also talked about this in the beginning, but now let's talk about in more details and see what's the benefits and the advantages of using a regenerator. So as you can see in the TS diagram, which is the temperature entropy diagram, the air is going to the compressor. It gets compressed in the compressor in isentropic process, so it will increases the pressure and the temperature from 0.1 to 0.2. So, and if there is no a regenerator, then the air is going to the combustion chamber in this area. So the air going to the combustor is T2, and then we will add fuel and the combustion will occur, which will increase the temperature, also increase the pressure of the combustion equipment elements from T2 until T3. But when we are using a regenerator, part of the flue gases heat is transferred to the air before it goes to the combustor. So it will increase the air temperature from T2 until Tx, and the amount of fuel used in this area is reduced. Also, the amount of other flue gases elements have been reduced. Also, at the same time, if you after that, the air after it gets burned or combustible in the combustor, it goes directly to the turbine, and this is the work done by the turbine in an isentropic process from 0.3 to 0.4, and this is the temperature of the flue gases going outside of the turbine. So the temperature of the flue gases going outside the turbine decreased into T4, and this is just the amount of temperature and the amount of heat that is wasted to the atmosphere. I want to address here that we cannot, I mean, it is it is not possible that we can make full use of the temperature because this will depend on the effectiveness of the heat exchanger, or in simple words, the efficiency of the regenerator, which is called the effectiveness. So this is the effectiveness or the efficiency of the gas turbine. This is the actual heat exchanger. So as you can see here, that the hot fluid is going from here, and this is the cold fluid going from here. Inside the regenerator or the heat exchanger, there is a heat transfer between the two fluids. So as you can see here, that the temperature going inside the flue gases here, for example, is going inside this heat exchanger. So this is T hot going inside, and this is the temperature of the cold fluid going outside of the heat exchanger. So there is a difference. There is a difference here, which can be explained by the effectiveness or the efficiency of the heat exchanger, as well here when the flue gases or the hot fluid going outside the heat exchanger, or the cold air or fluid going inside the heat exchanger. And this the difference also is what is called the effectiveness of the heat exchanger. This is the theoretical heat exchanger, which is not available in practical use due to the losses and irreversibilities that occurs between the two fluids. So this is the equation of the effectiveness or the efficiency of heat exchanger, which is the difference of the enthalpy of the heat gained by the air or by the cold fluid, which is Hx minus H2 in our previous. This is Hx, the enthalpy at the point X after the air goes outside of the heat exchanger, and this is H2, which is the air before it goes to the heat exchanger or the regenerator, over H4, which is the enthalpy of the flue gases going outside of the gas turbine, and minus H2, which is the reference for the temperature of the air or the cold fluid. So the other type is the recuperative. The recuperative is the same type as the regenerative, but it depends. I mean, the difference is in the design, because regenerative can be mainly in the type of cyclone or circular heat exchangers. The recuperative is also some types of heat exchangers. As you can see here, this is a pump or a blow that blows the air into the combustion zone. But before the air goes to the combustion zone, it goes to the recuperative heat exchanger, which exchanges or transfers the heat from the flue gases and gains some heat before it goes to the combustion chamber or to the combustion zone. So as you can see here, that the flue gases are passing through many passages to transfer much or as much as possible heat from the flue gases before they are released to the atmosphere. So there is also another type of regenerative heat exchanger in the form of honeycomb type burners. This type of regenerative heat exchangers is very important because it will lead to a reduction of it will reduce the amount of pollution of about 25%. It will also enhance the efficiency, and it will reduce the fuel energy saving by about 30%. Also, as we said, it will reduce the size of the equipment used in either a burner or regenerator in a gas turbine power plant. So what are the problems? As we said earlier, that this technology is very important and it has many advantages, but at the same time, there's some problems that I think that most of them are due to the need of novel materials which have to withstand high temperature in the regenerator or recuperator. So as we said earlier, that the amount of the heat in the flue gases can be from 400 to 1600, and this temperature is very high. So we are needing in the design and manufacturing of such device such new materials that can withstand this temperature, and our system, the regenerator or recuperative heat exchangers, will work for a long time in our system. Also, another problem is the frequent maintenance of the preheaters, because as we know that the flue gases contains many contaminations and elements such as carbon monoxide, nitrogen oxide. It has many other moisture, and it has ashes and many other elements which are results of the combustion, and these elements can damage and also can contaminate the system, which will lead to our system or our device not working properly, which lead to decreasing the efficiency of our system. So here, let's talk about the applications. But before we talk about the application, let's also recap what we have mentioned earlier, some of the benefits and advantages of using this technology, the high temperature air combustion technology. We have mentioned that some of these benefits are like saving energy and decreasing the size of the equipment. And here we'll talk about that the heat flux is distributed uniformly, as well as the temperature, it will be uniformly distributed. This is very important because when the temperature in the combustion zone is uniformly distributed, this has many advantages, because if the temperature is different from one zone to another, this will lead to thermal damage of our system because of thermal cracking and many other problems. Also, the possibility of burning fuel with very low heating value or low calorific value, such as heavyweight oil, such as mazote. Of this, so the application of this technology can be summarized in the following applications: regenerative gas turbine. This is the regenerative gas turbine. We can use it in the regenerative burner, also the recuperative burner. Thank you so much for your attention. If you have questions, please ask.